This is a video on horizontal and vertical tangent lines. The question states, find the points of horizontal and vertical tangent lines of r equals 1 plus the sine of theta. So remember that horizontal tangent lines occur when dy dx is equal to 0, and vertical tangent lines can occur when dy dx is undefined. So the formula for dy dx with polar coordinates is f of theta cosine theta plus f prime of theta sine theta over negative f of theta sine theta plus f prime of theta cosine theta, where f of theta is just the right-hand side, 1 plus sine of theta. So I just plug in. I plugged in my 1 plus sine of theta where I saw f of theta, and f prime of theta, the derivative of 1 plus sine of theta, is cosine theta. So I plugged in cosine theta for f prime of theta. So now let's simplify a bit. For the numerator, I'm going to factor out a cosine theta. When I do that, I'm left with a 1 plus sine of theta plus sine of theta, or 1 plus 2 sine theta, and then times cosine theta. For the denominator, I multiply through, and I get 1 times sine of theta with a negative or negative sine theta. I have negative sine theta times sine theta, which is minus sine squared theta. And then I'm going to take this cosine squared theta and write that as a 1 minus sine squared theta. So let's simplify the denominator a little more. We can combine like terms, and I get negative 2 sine squared theta on the bottom. And I'm going to factor out a negative 1 and change the signs of everything. So I get the same numerator. For the denominator, I have negative, parenthesis, 2 sine squared theta plus sine theta minus 1. The bottom here factors, and it factors as 2 sine theta minus 1 times sine theta plus 1. So now I'm ready to find the horizontal and vertical tangent lines. I find the horizontal tangent line by setting the numerator of the derivative equal to 0. So I set cosine of theta equals 0, and 1 plus 2 sine theta equals 0. The cosine of theta equals 0 whenever theta is pi over 2 or 3 pi over 2. And 1 plus 2 sine of theta equals 0 when sine of theta equals negative a half, and that happens when theta is 7 pi over 6 or 11 pi over 6. So let's plug in our thetas and get our r's. R was 1 plus sine of theta. So I plug in pi over 2, and I get 1 plus sine of pi over 2, which is 2. And I plug in the rest, and I got 0, a half, and a half. So there's my 4 points, pi over 2, 2, 3 pi over 2, 0, 7 pi over 6, a half, and 11 pi over 6, a half. And those are in polar coordinates. I'm going to convert that to rectangular coordinates by remembering that x is equal to r cosine theta and y equals r sine theta. And I got the points 0, 2, 0, 0, negative root 3 over 4, negative a fourth, and root 3 over 4, negative a fourth. And those are my possible points where there's a horizontal tangent line. And we'll see in a minute why I say possible. So now let's find the vertical tangent lines. So that means I set the denominator equals 0 so that the derivative is undefined, or the slope is undefined. So I set 2 sine theta minus 1 equals 0 and sine theta plus 1 equals 0. 2 sine theta minus 1 equals 0 when sine theta is a half, and that occurs at pi over 6 and 5 pi over 6. Sine theta plus 1 equals 0 when sine of theta is negative 1, and that occurs at 3 pi over 2. So I can plug these three values of theta in to my r equation, 1 plus sine of theta, and I got 3 halves, and 0 for each of these values of theta. So let's again plug it into the x equal r cosine theta and y equals r sine theta formulas. And I got the 3 points, 3 root 3 over 4 comma 3/4, negative 3 root 3 over 4 comma 3/4, and 0 comma 0. Now there's something wrong because a point can't both be a point where there's a horizontal tangent line and a vertical tangent line. In fact, what that means is that we get 0 over 0 for this fraction, this derivative. And it turns out that this derivative is truly undefined and there is no limit when we plug in our 0 comma 0 point. So that means that that is 0 comma 0 is neither a horizontal nor a vertical tangent line. So I disregard that point for my horizontal and vertical tangent lines. So let's sketch a picture. Here's the picture of r equals 1 plus sine of theta. And I can see that I have horizontal tangent lines right here at 0 comma 2 and also at negative root 3 over 4 comma a fourth and at positive root 3 over 4 comma a fourth. I have vertical tangent lines over here at 3 root 3 over 4 comma 3/4 and over here at negative 3 root 3 over 4 comma 3/4. And then right here at the origin, I get a cusp, neither a horizontal nor a vertical tangent line, but definitely interesting. And I'm done with the problem.